So this talk is bot basics in Java. My name's Summers Pittman, Twitter @SummersPittman, github.com/secondson. The reason they're different is because I picked the username Second Son when I was in middle school, and it's kind of like that scene in Jungle to Jungle where Tim Allen finds his son and finds out his name translates to like dog poop, because when kids are an inappropriately young age, they get to pick their own name. This is the mid-90s version of that.
So you don't have a GitLab account?
I have a GitLab instance I host. Because GitLab's open source and it has a really cool OpenShift container, and while I was learning OpenShift for Red Hat, I threw GitLab up on there, and it worked surprisingly well until I ran out of memory on my VPS and it crashed. With that said, I'm a software engineer at Red Hat. I work on mobile software and services as part of the AeroGear platform. This is the plug for my employer because they also sponsor us, us being AJUG. I'm also on the AJUG board. I'm a Georgia native. I have lived in Atlanta with a small exception since 2003 when I came here for Georgia Tech. The fact I went to Georgia Tech affects what basics means. I'm not going to really be getting into all of the different APIs and virtual assistant SDKs and stuff like that. This is going to be talking a little bit more about natural language processing and kind of the usability and UX of bots. So basically the talk's going to follow this format: what are bots, what bots aren't, how they work. So that's when we'll get into the different types of chat box and kind of what they're doing under the hood, and a little bit of real coding examples. That follows into tools where I'll kind of lay out a couple that I've experimented with. And then finally techniques for writing bots, which, as I said, goes back to the UI, UX experience for bots. Not so much UI, UX, but more just experience. So what are bots? For the purpose of this talk, bots observe text. They formulate some sort of statistical model about text, and they interact with humans using natural or nearly natural language. One of the original bots was a chatterbox called Eliza. It was part of a research program in 1964, 1965. So bots as a technology are 53 years old, which might actually be older than some of the people in this room, or most of the people in this room. The way original, and that's kind of merged into what we're seeing now in the consumer space as AI bots. So how many people will get really mad at me if I say the hot word and their phone goes off? Okay, Google, play some music. Oh, got one. Bots aren't this. Bots are not these crazy, monstrous things that are going to take over the world. They're more like this: friendly, monstrous things that are going to take over your wallet and bank account. Stop it. Sorry, my phone actually was taking off. And there are a lot of these virtual assistant projects. There's Cortana, there's Siri, there's Google Assistant. There's Facebook's bots for Messenger, which is really cool. I have been seeing it more and more where if you're chatting with somebody, it'll be like, oh, hey, it looks like you're talking about planning an event. Would you like me to create an event? And it's everything but the paperclip. The one in the top right is actually this open source project called Mycroft AI. I haven't played with it, but I figured I'd put it up there since it's open source. I've kind of been going on a little bit, but so how do bots work? How many people think they know how bots work? Yes, aliens. No. Magic. Still no. So bots work by using a technique called natural language processing. There's several different parts of this. One part is hot word detection. This is actually kind of the easiest thing, where you just check a text string for the appearance of a word or not. If you're familiar with IRC bots, a lot of times you'll be able to address the bot, give it a command, and then give it parameters. But the structure of the commands are more text-like. So I wrote a chatbot for my IRC channel that I use to talk to my coworkers, and it'll be like, bot, tell Passos, look at my PR. And the bot will say, okay, and the next time Passos comes online, it'll deliver that message automatically for me. And when I'm being really creative, it will send a push notification to my Android phone or to Passos' Android phone and give us some updates, but that's neither here nor there. We're probably much more familiar with the Giphy bot in Slack and Rocket Chat. How many people here have Giphy in there? Yeah, Slack, Rocket Chat. For those of you who don't know, you type /Giphy and then say something pithy, press enter, and it shows this. It shows a meme. Other parts of natural language processing are document categorization, fancy word for spam filter. Turns out it's good for more than just detecting spam. Sentence detection, so is this a sentence a human wrote or is this gibberish? In the case of gibberish, it might be, is this like code, markup, or some other type of text? Name finding, so hey, we know this is a sentence. Hey, we know this is a not spam email. Who is it from? Scan the email, find proper names, find names of places, find names of this, tag them, and pass them on. Entity detection is something a little bit more general than name finding. What entity detection does is it lets you train your bot to recognize that in a phrase, this thing is valuable information that you want to hand off for further processing. I'll talk about that a little bit later when I talk about Lewis, which is Microsoft's natural language service. So basically, bots work by science. If you want to get into the nitty-gritty technical stuff, there are lots of statistical models and lots of papers that are very, very detailed, very well explained. There are tons of books on the subject. One of the ones that I've been reading is Natural Language Processing in Python, and it seems to be pretty good. There are a lot of open source projects that are usually backed by universities that have a lot of the training data already done for you, so they're kind of pick up and go. So I've talked about how bots work. Let's see one work. This is a bot I wrote called StockBot. You ask it the price of a stock. So what's the price of Microsoft? The bot says it's looking it up, gets the price. I give it a different command, it does it. I give it a command it doesn't understand. It gives me a polite, I'm sorry, I don't know how to help you. We look at, and then I say, okay, give it a command in a format it understands that matches the model it's trained against. Okay, I'll look up Red Hat. Oh, and then there was an error. I'm sorry, I'm having trouble with that request. In this particular example, I'm using a free stock lookup API, and I hit my quota. So in the middle of getting a screenshot for a demo, it happens. All right, so this sounds like a lot of stuff, but as I said, there are tools and there are projects for how you can actually use this. There are natural language processing libraries that are available in a multitude of languages. Tonight I'm going to discuss OpenNLP, which is an Apache licensed and an Apache project language processing library. And also, as I said, a lot of times these libraries have language models. At this point, I want to take a stop and describe kind of what a language model is. Part of machine learning is a lot of training data. So what these projects have already done is the effort of taking huge amounts of public domain literature and articles and other types of text and annotating it by hand and feeding it into these processes, having these different statistical tools analyze this annotated information, and then validating it against new information and new documents to make sure that the models hold up over time. It's a very labor-intensive process. It's a very manual process. But fortunately, for the most part, once it's done, you only have to do the little bit of extra work of reinforcing the model and correcting bad behavior. If doing all of this work and maintaining these libraries is not up to you, or not up to something you're not up to. They're online services. So Microsoft has Azure services for bots where they will have different types of natural language processes, have different types of hosting processes, have different types of like chat bridges for you to get to different sources of text information. Amazon and Google both have skills for their AI platforms. I don't know about Siri. I'm sorry, I don't use a Mac. I've only used a Mac once. It was a miserable 8 months. So there are online tools as well that you can use if you're in a situation where that'll allow. For what it's worth, if you're in the medical industry, you probably want to lean towards the NLP library that you host yourself and not sending all of your patient data to Google or Azure or Amazon or the FBI or Russia or, pick your poison. Yeah. And then also hosting. Bots are usually not RESTful. They're usually have some sort of open connection. So whenever you're doing hosting, you want to be aware of that. It might be using a WebSocket, it might be using a TCP socket, IRC, whatever Slack uses. So there's things you might have to be aware of. So I've mentioned Microsoft Lewis. It is a cute acronym. I don't remember what it says, language, utilities, information, I don't know. But what's cool is you can send it text, you can send it training data, and it can say things like, oh, hey, this text you sent me matches this other text you sent me. And the difference is that this first text you sent me, you told me it was a stock question for Microsoft. This new text that you've sent me, I can tell it's a stock question and I think it's for Red Hat, or I think it's for Oracle, or I think it's for this, or I think it's this other thing that you've told me about. It has a really cool UI. When you set up a project, you set up intents, which are things that I want you to respond to. And in my particular case, the two things are either look up stock or this is nonsense from the purpose of the bot. And then you have entities, which are things you want Lewis to extract and give you. In this particular case, there's a ticker symbol. So I'm just going to really quickly open up. I'm in full screen. All right. So has anyone here used Lewis or Azure's bot services before, or is this new to everyone? You had one? Okay. All right. So I'm not going to go into all of it because there is a lot. Why aren't you signed in? All right, so this is Lewis AI. You can have different applications. It's the same as lots of other services in that regard. So this is my chat service. And you can start to see some of the things I was talking about earlier. We have training, where you can upload a training data set, which is just a JSON file of annotated utterances and anti-utterances. There might be somewhere in here where I can find that. You can create intents, which are, hey, these are actions I want you to look for the opportunity to take. So here you can see where I've uploaded a training set for this particular intent, and it's what's the price, what is, da-da-da, and lots of things, and then I have this annotated item that if you mouse over, you can see what the original data was. And these are queries that I wrote by hand, uploaded, and then said this part of the query is, all these queries are the same thing. This part of the query is the information that I care about. And Yeah, so that's Lewis. All right, now let's see if the chat, and this is the running chat box, so I can say, look up MSFT, and it'll probably, I think you were asking me to look up a sock, but I think you forgot to add the ticker. So in this particular case, it didn't catch the utterance, but it gave me a friendly error message, which is something we'll talk about a little bit later, because you don't really want to be talking to a bot and then suddenly get it to go Stack Overflow exception, class found, not found, yada, da, 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 something nasty. In this particular case, it might actually be that the intent came back and the JSON was not formatted. So in that case, let's go for what is the price of MSFT. Submit. I'll look up MSFT. This time it actually got the ticker price. That's what I will look up for. It's going out to a service. The service is doing something. The service might be down. Yeah, sorry, I'm having trouble with that request. Also, what I said earlier about the fact that I had been testing this at home and hit my quota might also be that. So we can step through the code real quick. Lewis uses just RESTful calls, HTTP calls. So in this particular case, when you press enter, it does a whole bunch of swingy stuff to get things on the right thread and ultimately calls this method where the message that you typed in is appended to a URL that has my application key and application ID attached to it. OK HTTP builds the request, the call is made, and the response is parsed with JSON into this Lewis response, and this is the actual Java model of the JSON that we get back. If we want, I can actually just print this out. JOptionPain.show message null, comma, response JSON. And when you run, and so when you run the Lewis query, you get a JSON response back from that service. And so you get the query back, you get some data about it, you get the intent, which is the thing it thinks you're doing. If this was, hey, can you order a ticket or can you do something else, and I had trained it for that, the intent would be different. You also see that there's this other intent, none. One of the important things about your training data is not only you need stuff that is positive, this is the thing I want you to look for, you also need to train it, this is the thing I want you to not look for. It's kind of counterintuitive, but it makes it work a lot better. It's one of the reasons why, if you remember the Spam Assassin tool, when you had to configure it way back in the day, or anyone who's ever set up an email server, you would have to not only give it a spam set of emails, but also a ham set of emails, a good set of emails, so it is able to calibrate better. But in this particular case, we can see that it is 98.66% sure that I was asking it to look up a stock. And then it gives me the entities, which are the, again, it's kind of similar. Hey, this is the string I extracted from your query, from your utterance. I think it is this type of data. Here's where it is in the string, and here's how confident I am. 51.98% sure. That's actually kind of low. And this time it worked. So as you can see, it went out and it called a stock service and got a name. I can show you that code too. Woo, it's making a REST call with a parameter. Who here has never, ever, 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 ever written a REST call? You actually have, because if you ask the guy who came up with REST, how do I do this in REST? He says, or can you show me an example of this done in REST? He says, yes, open literally any web page. He is less than useless for doing things, for what we use REST for.
I have a question. So how does it know that MSFT is that, if you replace the different company's symbol, is it based on, I understand it's natural language processing, but how does it know at what point to stop in the question, right? what if I say, what is the price of MSFT and CNN and fake news? And it's just gonna show up?
I don't know, let's see what happens. All right, so it thinks I'm asking for a stock. It couldn't find any intents. It's like, I mean, any entities. So down here, this entities collection is empty. So what this tells me is it, in the training model, it was able to realize, hey, these are stock tickers, and a box of cakes is not doesn't match any of what it understands a stock ticker to be. If we give it something more complicated, like what is the price of MSFT and Red Hat, it's probably not going to know. It's a, oh, it notices I'm looking up stocks, but again, because of because of the training data I've never shown it this before, so it can't find the stock ticker. And if we go back to here, intents, you can see the training data that I've sent up, and it's 1, 2, 3, 4, 5. Looks to be about like 25 entries that I've trained it with. So I haven't trained it really well. In all honesty, I did this in a meeting while I was wishing that the machines would rise up and kill us all. Way back at, I don't know, 2016. That was a long time ago, right? But no, like, the thing I liked about Lewis was you could very quickly get something up and running, but like I said earlier, training data is huge, and I have a demo later on where I'm using a classifier on my AJUG inbox, which is about 700 megabytes of emails from 2008, I want to say. Vincent, how long have I been on the AJUG board? Do you know?
Forever?
Yeah.
6 years.
6 years? Maybe. Yeah. Okay. 2012. That sounds about right. So, yeah. So 6 years.
Question. So, if you don't have to train this, like this is Microsoft's train model, why are you limited to only like the stock price?
Oh, I did train this.
Oh, okay.
This is Microsoft hosting the training for my model. So, one of the things that Microsoft is doing in the backend, it might just be what Microsoft's models are providing is more context for picking out the ticker information. But for the most part, all of these utterances, which are the phrases that you send to the bot that it's looking at, are things I provided. Microsoft's hosting the libraries and the backing models for those libraries that are able to do things like this is English, this is Spanish, this is Russian, this is gibberish, and things like that that help you along and get you to this point. Right. So anyway, but the training models need tons and tons and tons of data, and for one of my demos up now, I had my entire AJUG email inbox imported and was training it to recognize the different types of emails we get a lot. As an example, hey, this is a CFP. Hey, I can't make it. Hey, when's your next meeting? We do get a lot of the same emails over and over again. And before I could start getting results that were relatively good in just a what is this with 4 categories, I needed to tag about 300 emails. So, like I said, the data can get very huge and very tedious. That's what interns are for. All right, so. But that was Lewis. That was it. It's easy. It's simple. If you want to impress your boss and friends, you can do a quick stupid human tricks on it or stupid computer tricks, and it looks awesome. And then when people start saying, "Well, what if I type in something that isn't a single stock ticker?" It falls apart really quickly. All right. The other library that I'm going to talk about tonight is Apache OpenNLP. This is something you host yourself. It is a Java library and also a set of command line tools. So if you are in an industry where you don't want to host stuff in the cloud for whatever reason, or you're building your own NLP product, or you're doing a demo in front of a bunch of people, and you don't know if you'll have the internet, then you'll probably want to look at this. There are tons of other projects like these. Python If you don't know Python and you're interested in NLP, you need NLP and bots, you need to learn Python because that's where the vast majority of the research and products are. The fact that there's one for Java was shocking to me. It was even more shocking to my coworkers who are under 25 and have only ever done Node.js and JavaScript and were just baffled why there wouldn't be JavaScript libraries for natural language processing. And it was gleeful to tell them, yeah, there's a Java one. So the website's opennlp.apache.org. It provides, like I said, Java APIs and command tools. It's a big toolkit. There's lots of things it can do. It comes with lots of pre-computed models. So earlier when I said, hey, one of the things that Lewis does is it can tell you whether or not something's in Spanish or English, Portuguese, Russian, Brazilian Portuguese, Castilian Spanish, Mexican Spanish, yada, 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 yada. Apache's already done all of this training, and it's a program you can download, and you can just throw text at it, and it can tell you what it thinks it is. And you don't need Lewis for that.
How does it know the context? That's what I'm missing. How does it know that if I say, what is the price of coffee in the international market today? Let's say I throw the question at it.
Mm-hmm.
How does it know the context? Coffee could be Starbucks coffee, right? How does it know?
Well, there's a lot of context in there, and giving all of the data you have ever given it, which could be thousands of what is the price of blahs, you eventually have enough training, enough tagging, enough just tables of data that it can start assuming context from what you've given it. I use the term assuming very, very loosely, but it basically says, this is what you've said. When I've seen people say similar things, this is what they were asking for, so I'm going to tell you that. And remember when I was showing you the intents, how that came back in an array and you had several to pick from, and you could see, I'm 90% sure, I'm 80% sure. You can get those confidence intervals for the algorithms that all of these are give you confidence intervals. So you can always say, well, I know that it might be this, but let's also look at these other things. So if the person says, hey, this is wrong, you can say, well, there's also this. It's basically the equivalent of the second page of Google results.
And that's what the interns are doing, right? I mean,
And-
basically the interns are selecting the intents, the correct intents for the association. Is that how you do the training?
Right, exactly.
Basically, you're going through and it's like, I think it's this, this, or this, and the intern says it's actually this one.
Right, exactly. And when you're a company as big as Google and you've got data models for 2 billion people, you can make a lot of really good assumptions. And when you get to the point where you can make models about people and you can bucket people and then say these people in these buckets get these models because when they ask me questions, they're trying to ask silly gotcha questions and I know to take from the second page and not the first page. Like I said, it looks really impressive. And then you realize it's just a whole bunch of statistical models and linear algebra. If you don't know linear algebra and you really want to get into this, you're going to need to learn linear algebra. I didn't learn linear algebra for this.
It's not too bad.
No, it's not too bad, but it's stuff I don't want to do. And hey, look, there's Apache and there's Microsoft who do it for me, and Apache doesn't charge me for it. So if I was talking about how great Apache OpenNLP was and all of the cool stuff it can do, and I didn't show you do it cool stuff, then that wouldn't be much good. So where's the other demo? Here it is. Like I said, this is this is a whole bunch of years of AJUG email that was sent to info@ajug.org, like Vincent was saying. I've been training Apache OpenNLP against this to recognize 4 categories. CFP, which is our automated systems response. Whenever you send a CFP in, we get an email with what you said you wanted to do so we can review it and figure out what tracks we want to have. Not a CFP, which is my catch-all for this is conference related, but it's not a CFP, it's not spam, and it's not a conference question. Conference questions are things like, where do I park? Hey, I can't make it. Can I give my badge to my friend? What are student IDs? Just questions that we get asked a lot, and enough that I can have that. While I was training this model in the whatever that kitchen room is, it was getting to the point where it could start distinguishing between this is a question about the conference and this is our answer to the conference. So the question got the question and the conference answer got the not CFP label. So how does this actually work? Here's an email. Saw your tweet, thanks. Said half day. We have it down as a full day workshop. Do you have enough? All right, that sounds like a question. Oh, I've already tagged this as a question. Awesome. Here's a CFP, so I tag it as a CFP. Here's a registration confirmation, tag it as a not CFP. This is a question. This is a question. No, this is an answer, so that's not a CFP. This looks like spam. So I have a whole data set that I've trained like that. And what I want to do now is export it into a format that OpenNLP can understand. So I hit that button, and then I will just show you what the training data looks like after it gets cleaned up. So what it looks like is it's the tag, and then it's a sanitized version of the email. One of the things that you'll do a lot is clean up awful text. Email is the awfulest text I have ever seen. We don't have enough time tonight left in this day for me to talk about how awful parsing inbox files is. So this is a really cool demo, and I hope you enjoy it. And I am not suffering from anything because of it. Yeah, and so I have 164 categorizations that I did over the course of about an hour. I mentioned I had 300 earlier. That's on my desktop, and I forgot to bring the training set with me, so I had to redo it by hand in about an hour before the talk. Once I've exported it into a training set, I import the training data using this train categories, and then I can click on something that isn't actually categorized, and I can test it. And it says, hey, this looks like it's not a CFP. I would like to volunteer. What times? This sounds more like a question, so I can actually correct its guess and export that, retrain it, and then if I have, well, someone sent the same email twice. Thanks, guys. If I do this again, it notices, hey, this is a conference question. And of course it is, because I told you before this was a conference question. But yeah. And so we can keep testing it. It thinks this is a conference question. That's actually an answer to a conference question, but it was in response to a conference question, which was, can I transfer an email registration to a friend? So, like I said.
This is a stupid question, but is this a utility that's provided by OpenNLP, or is this the app that you wrote?
Oh, this is the app that I wrote.
Okay.
All right. So hopefully you can kind of see what it does, and that it's not that smart, but it is able to start making intelligent guesses. So like here, if I test the categorizer, it predicts that this thing, which is a CFP, is a CFP. What's cool is that I tested it on 2005, 2015 data. I left 2016 alone, so it has learned a little bit that, hey, this is a CFP email, even though it hasn't seen this particular one or even this particular format. So, yeah. No, don't do that, All right, so let's kind of dig into the source there and show you how OpenNLP is set up under the hood. This is, you don't want to look at my Hibernate stuff. So, not there. Here we go. All right. So this is the UI that you saw before, and here's the actual. Are we doing this, NetBeans? When I click on the train button, it opens up a file that I generate, temp dev nexus training. This is the file that I opened earlier that had 164 entries that I was explaining the process to. Does some boilerplate, sets up some training parameters, how many iterations do you go on, what's the cutoff, which is at a certain point, you stop getting changes in the data, but those numbers keep getting really, really small. How small do you want it? These are the defaults. This is what's called a Bayesian trainer. So Bayesian answers the question of, is this a thing or not a thing? And if you have multiple categories, you have thing, 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 not any of these things. And Bayes is really good at that. This is basically spam filtering. This is the algorithm that spam filtering does. And then I call document categorizer.train, and I say, okay, this is English, here's my samples, here are my params, which is what I was talking about, the algorithm, the number of times you iterate and how and when do you stop iterating, and then some more boilerplate, and that creates the model. The model is what I've been talking about this whole time, that for the most part, for a lot of things, it takes lots and lots of data, and we create it. Document categorizers are very domain specific. They're specific to your use case, they're specific to your users. So you don't want to make a generic classifier model. There's no such thing. Models that we can provide, though, are things like part of speech taggers, sentence diagrammers, sentence detectors, proper noun detectors, things like that we can do, and language detectors. And so if we were making this more complicated, we could get an email in, we could run it through a pipeline of multiple of these things, and depending on the outputs of each of those models, we could send it somewhere else. And then when it's actually time to test a categorization, we get our model here. We run the categorizer, we give it the model, and we ask it to categorize the email. And basically all this is, hey, take that email, put it into a format that the categorizer can understand, strip out some extra stuff, and what do you think it is? And so we get this outcomes array, which is the percentages of each category it thinks it belongs to. So if we look in this output here, we look in our output here, we can see the probabilities that a particular email was a conference question, a CFP, a not a CFP, or spam. This was the one where it was the same email twice. So we have a 1.0 confidence, but then we also have these very small but not zero percentages of it might be something else. Again, this is what I was talking to earlier about how these algorithms are all statistical, they're all probabilities. So when you're iterating and training, this information feeds into itself over and over and over again, and eventually they stabilize, but they're still becoming more accurate, and you have to tell it when to stop. And that's what one of those parameters I was talking about earlier is. And then you just take the one that's highest and say, this is what I predict. Oh, yeah, I had a nice picture that was all blown up and wouldn't give anyone a headache to try and read, other than the fact that this is data for a machine and not data for a human, and is almost gibberish. Oh, and hey, look, my demo in case it didn't work. I have this on GitHub. I apologize if things don't work because you don't have the AJUG email corpus. No, you can't have it. But you could actually download this, download your own Gmail and experiment with this tool yourself. So if you want, you can use Google Takeout to get your inbox file for your Gmail inbox, and you can start categorizing your own email and experiment with the technology that way. So now we're kind of into the home stretch on this. You have a general idea of how you write a bot, how you do things. What are some things you should be aware of? So bots are dumb, but they can give people a lot of context about what they're expecting. So you have to think about the context you want to drive your users for and the context you want to look for. In the case of Facebook Messenger, it's probably using document categorizers, using models that you've given it, like I did with the stock bot and Lewis, to know whether or not it should hand a message to your bot. And that's when the bot will pop up and be like, hey, I noticed you're talking about going to a play. Would you like to know plays, would you like to hear about plays, and then do a little bit of geolocation near your area at the Fox Theater? And that's a yes or no question. If you answer cake to it, it knows cake is not yes or no, and it can say, I'm sorry, I don't understand. Would you like to see this, yes or no? Or say stop to make me go away. And then you say stop and it goes away. So what you want to do is you want to prompt the users for the output you're expecting to try and narrow down the corpus of everything a human can possibly say into just a few words. And then as more people interact with your bot, you get more text data, you have more stuff for the interns to do. You know when things went wrong, you know when things went well, you know when the bot wasn't sure. And you can train it better that way. And then also finally give friendly error messages. Again, oh, I'm sorry, I didn't understand that, not context exception, your threshold for an utterance fell below 0.05D. Please contact info@AJUG and report this bug. So yeah, like I said, as I said earlier, use your own data. So for document categorizers, again, this is very domain specific. Have anti-examples. So if you say, I want to categorize all of my bug reports, okay, what are you categorizing them as? Bug reports. Well, that's easy. It's just GitHub issues, and you download that and you're done. But if you want to categorize good bug reports versus bad bug reports, that's when we're getting somewhere. So the, hey, I had this problem, here's a stack trace, here's a this, good bug report, it doesn't work. Bad bug report. These are traditionally called spam and ham. Good things you want to test for, things you don't want to include in your test. Okay, I got ahead of myself again. Prompt for user confirmation, lead your users down a regular path, yada, yada, yada. Yeah, and that's kind of where it is. Like I said, this is really like basics, introductory to what you do, what things are, how things work. There's a lot of tools that I could have gone into. There's a lot of products that I could go into. I could sit here and say, hey Siri or hey Cortana and troll everyone who's, I don't know if it's picking up or not. I'm not going to say OKG because that ruined my phone. But yeah, so that's the talk. Questions, tomatoes?
So in some of your source code, you were using Swing, which would, the easiest way to deliver that is with Java Web Start. My question is, in the field, when people are writing bots, what are you most frequently seeing as a UI? I mean, it's not going to be pure web. That doesn't seem to fit very well because you have so many issues with, you know, a new browser window, a new tab. It sounds like it's got to be embodied in some sort of either Swing or thick client experience or something. What are you typically seeing for in the industry where people are building these in from a presentation point of view?
So the question is, what do we see in the industry for what people are using from a UI point of view? And the answer is it's a lot web, but the bot instance has several informations to track a conversation. So in the case of Google, it knows who you are, what your user account is. It knows conversations you might be a part of.
Or on the back end?
Oh, on the back end. On the back end, it's...
The thing you just said, it knows this stuff. It has to know that through back end logic because...
Yeah, you've logged into a device, which is your session.
Okay.
And so a lot of these are in the cloud. So Azure Bot Services run on Azure. Google's Assistant runs on Borg. I don't know what Siri runs on. I'm guessing a couple of hamster wheels and a Volkswagen Jetta's like HUD. But like you know, so.
You did yours in Swing. That's what caught my attention.
Oh yeah, I did it in Swing because Swing is easy.
Okay.
Because NetBeans has this really cool UI designer and it just works with anything in Java. We don't have to say annoying things like, okay, now that you've compiled and run your Java server and gotten your database running, now what you need to do is open up a web browser and go to http:// Oh, look, you have a firewall rule blocking this. Doing it in Swing, let me just keep everything in one application context and simplify all of that stuff that I would have had to track, like who's the user, where are they from, keep track of their conversation, yada, yada, yada.
So this bot talk that you just did, right? So it's like building your own bot server with the intelligence data coming from different models, right? What about the other side of it? Just want to behave like a bot client scouring a Slack page, looking for keywords and saying, like chatbots, right?
A chatbot.
Yeah, I mean, are there already pre-built clients? Is that why the talk is not about that? Or?
The talk isn't about that because the talk is about bots in general and not Slack bots.
No, not necessarily Slack,
Yeah,
right?
so-
I could do other chatbots, right? I mean,
Yeah, okay. As is tradition, there's my web browser. I have an IRC bot I wrote a while ago in C#, and that's why you didn't see it tonight. It runs as a process on a Linux server. It connects to IRC. You give it a list of channels to be in. Everything that comes on the channel, it looks at, it runs against, in this case, it's a hot word matcher. Checks all of the hot words, sees if you match any of the patterns it knows, and then it builds an action out of that matched pattern.
I mean, in our company, we have a chatbot that we use out of the box, CoffeeScript based chatbot listening to all Jenkins conversations. And somebody says, do a bid for this. Okay, I'm going to kick off a bid, right? This is language is defined, the grammar is all there, it listens for keywords, right? I mean, are there already pre-built Java libraries or pre-built Java applications which are doing this?
I'm sure. I didn't look that hard. I know that there are Java libraries for Azure's bot services. Azure's bot services have pre-built libraries for connecting to Slack, Rocket Chat, IRC, email, lots of other things. So probably what you'd be doing is you'd be using the Azure service to write your logic that takes utterances that Azure picks up from Slack, process those using the Java SDK, and then do whatever your logic in your domain is. And there are products that are built around that. So whenever you are given, hey, here's how you talk to the chatbot, you say chatbot command parameters. And that's probably hot word detection, which is still really gets you really, really far. That's how the original like Eliza chatbots and stuff worked, and that's how a lot of the early AIM bots worked. So that's probably what it's doing, but I didn't really want to get into that, mostly because it took away from the more basic parts of what's actually going on and what are the techniques that are happening under the hood. And once you understand what's going on, you can apply it to anything, Python, Java, Lisp, what's that other language, C#, JavaScript.
Whatever you have written, right? You showed the demo. I'm sure somebody's already made a jar out of it and just said, drop it in, I can talk to an Apache NLP, or I can talk to Microsoft Lewis.
Oh, yeah, I'm sure someone has already done it, but I wasn't looking for those, and that's really not what I was presenting. But if you want, you can just Google Java bots, and let me turn on my hotspot on my phone.
I don't think it's necessary.
Yeah.
We understand that you were reinventing the wheel. But
Exactly. It was
But it was to demonstrate.
it was an
a
academic
concept.
exercise.
Yeah, it was to demonstrate a concept.
Yeah.
Yes, I get it.
All right. Any other questions?
Well, since we're going completely off topic,
Oh.
I've got a random question.
Okay.
After him.
And you first, and then.
Yeah, so you mentioned categorizing emails like ones about parking or about tickets. So say you go through 1,000 things, you categorize them, and then you realize there's more specific categories like directions and parking or selling tickets versus buying tickets. Can you add additional categories, or do you have to go back and redo everything, or how does that work?
So there's two things you can do. One is you go back and redo it. Or the other one is if one email is a strict subset of the other. So this is emails about travel, and you only tag travel, and then you realize inside of travel you want to have more granular. You can actually create another module, another model that's taking the travel emails and then breaking them down by that. And you have the benefit that you've already reduced the scope of what you're looking for. So the hardest part will be, is this a travel email and not is this a directions versus parking email? But that's what I was talking about earlier. That's another application of you try to lead your users. If this were an interactive thing, you'd want to lead your users down a path where you're getting, a subset of the sum of everything a person can say. Okay.
I was on the AT&T website this weekend looking for high-speed internet,
Mm-hmm.
and I used their chat.
Mm-hmm.
And in the conversation, I asked them, "Are you a chatbot?" And there was like a really long pause, and then it came back and says, "No, I'm a human being ready to help." So I was just kind of curious what you thought happened there.
So they've probably have either hot words looking for chatbots, and if someone says that, go, okay, someone cares enough to ask, we'll send it to a human, because they have enough data and metrics to know if someone is annoyed that something is a robot, it's not helping. And if someone's asking if something is a robot, they're probably already annoyed. So that's probably what happened. Or it was always a person, and
And they're annoyed.
and then they're annoyed, yeah. Or it was a robot lying to you. It could have been a robot lying to you.
That's true. There were three options, and you just named all of them, so it was interesting.
Yeah. More questions? Yes.
Yeah, the whole idea of single self-contained utterances is kind of, bottom tier. I'm just wondering about the context of a conversation as it becomes a back and forth kind of thing. Do these libraries help with that?
Some might. I know that context and back and forth conversations are really, really hard, especially if you're allowing for more free-form things. This year at Google I/O, Google had a long, wonderful demo that you need to turn your phone off for, where they were going through conversations with their assistant, and it ultimately ended in one where they had their chatbot using voice synthesizers calling people and doing stuff for you. So they had a demo where a chatbot called a pizza place, or called a salon and scheduled a thing between a time. They had another one where it called a Chinese place and tried to make a reservation, and they're like, we're a counter, we don't do reservations, what are you talking about? And it was able to handle that gracefully. So to your point, I'm sure these would, but this is an area of really hot research right now, and there's a ton of money being put into it. Yeah.
So,
All of this has been categorization questions. If you try to detect the mood of a conversation, and that's basically sentiment analysis, and that's a regression problem, right?
Probably. I didn't dig into sentiment analysis, mostly because there's a lot of different topics and they all have different math that I wasn't going to learn. But yes, sentiment analysis is another thing, and I did see some libraries tried to provide it. I know Facebook got in really hot water for doing sentiment meta-analysis, where it was changing what it was sending people and seeing if they could change the sentiments of the people's posts over time. So yeah, sentiment analysis is a thing, and I saw libraries that offered it, and I didn't test them because I don't want to solicit angry messages on Facebook from people as a training data. Any more questions? Oh,
The training, is it basically machine learning?
yes,
It's
the training is machine learning.
populating a neural network?
I don't know if it's a neural network under the hood or if it's any other, what the actual model it's using under the hood. Certainly some of them might be neural networks, but the short answer is I don't know. I know for things like hot word matching, it's not.
You were saying something about Bayesian, so that was a specific.
That was a specific algorithm, yes. It was not a neural network.
Is there a reason why you went with OpenNLP instead of Stanford NLP?
The reason I went with OpenNLP instead of Stanford NLP was because it showed up first in Google and Stanford NLP was second. And also I got it working first. If it wasn't working today, I would have tried a different one. But it was just luck. All right, I think that's all the time we have for now. If anyone wants to catch me afterwards, by all means. If you want to get drinks and talk about other technologies, by all means. And thank you for coming.